Now, the next thing is about the universe formation. When we talk about the formation of the universe, there is one very important theory that always comes to our mind, and this is the Big Bang theory. So, what is the Big Bang theory? We'll understand this. But Big Bang theory is a theory, right? There are other theories as well. There are many other theories, rather, but most of these theories have not been effective in explaining the universe, in explaining the how the formation of the universe might have happened. How do we see the things that we see today? So all these are not very well explained by other theories. So that's why all the other theories are not as popular as the Big Bang theory. So from examination perspective also, what you need to understand is the Big Bang theory and the things related to the Big Bang. The rest of the things are not going to be important. We'll look into them in a very small manner. In one sentence, two sentences, we'll just try to understand what they are. Now let's talk about the Big Bang theory. In the Big Bang theory, first of all, let's try to simplify the things before we go into the details. What does the Big Bang theory say? It simply says that our whole universe, everything that you see today, it was a very small particle. It was a very tiny, hot, concentrated particle. The size of this particle would perhaps have been even lesser than the size of a proton. So, very small particle. In this particle, everything that you have today existed. All the matter, all the energy, all the forces, everything in this small particle. And then, ever since then, the universe has been expanding and cooling. This is what the Big Bang theory says. Very small particle, all the matter and energy inside it started to cool, started to expand, and ever since then, this is what has been happening. This is Big Bang theory, nothing else. Now, how did we come to this conclusion? How did we come to the fact that, okay, the universe as we see today was not as it is today? It was another particle, it was just a very small particle, it was not steady, it was not uniform as we see today. How did we come to all that? So, there are certain evidences that support the Big Bang theory. There are certain things that we know about the universe which actually set into the model of the Big Bang theory. What are these? And knowing about this is very, very important. Three evidences. One which is called as Hubble expansion, one which is called as cosmic microwave background, and the third, Big Bang nucleosynthesis. What do we mean? First of all, when we talk about the Hubble expansion, it means the accelerated expansion of the universe. Today we are saying that since 1990s, we have come to the conclusion that universe has been expanding in an accelerated manner. Right? 1998 there was a discovery that happened. This was because of the work of Hubble Space Telescope. Now, Hubble Space Telescope in 1998 was able to find this, was able to discover this, that universe must be expanding at an accelerated rate. So this is something that is also supported by the Big Bang theory. Now you have to remember that the Big Bang theory has been there since the 1960s, right? So a theory which was given and later on has been supported by some of the other data that we have seen, other evidences that we have come across. Apart from that, we have something which is called as cosmic microwave background. And this is a term that you will very often see in the newspapers as well. When the Nobel Prize was also given, in the Nobel Prize also cosmic microwave background was mentioned. Now, because of this fact, we know that cosmic microwave background is very often in the newspapers as well. So that's why you have to understand what is the meaning of this term. When we talk about cosmic microwave background, we basically talk about the heat that we are able to observe, the heat signatures that are available, which are observable for a telescope whenever we try to observe the entire space. So something which is visible in the background. How do you imagine this? Again, let's go back to coal. Try to imagine a burnt coal. What do you see when you observe a burnt coal? You see a reddish color coal, correct? It is not giving you energy anymore, it has burnt out, but you do see heat signatures. You know that, okay, this is something that burnt, but now it has cooled up. Now we don't observe anything, we do not get energy out of it, but the reddish color just signifies the fact that it was burning, it was very high energy, it contained very high energy, right? This is what you know. So something similar you can think of, that when you talk about the birth of the birth of the universe would have been a very highly energetic process, that all of a sudden something happened that led to the expansion of the universe, led to a kind of explosion. We do not call it explosion, but you can imagine it like an explosion, that all of a sudden this expansion started to happen. So yes, this would have been a very highly energetic process, and that's why we can actually observe heat signatures in the background whenever we try to observe the universe. This is something which is called as cosmic microwave background, because this is a kind of a cosmic background which is in the form of waves, which is in the form of heat waves. So heat signatures are visible. So if you look at the picture that you have on the screen, what you observe is that there are three figures that you see here, right? Number 1, 2, and 3. These basically signify the heat signatures from the time that the universe was born. This is something which is called as the cosmic microwave background. So cosmic microwave background is something that was predicted by the Big Bang theory, and later on it was discovered. So if it was on the basis of discovery, it would have been very convenient. But that was not the case. Big Bang theory said that yes, it should be something like this, and later on observations were made. The three figures that you see are by three different probes. This is the first figure is of COBE, COBE. This was one mission that was launched by NASA back in 1993. COBE basically stands for Cosmic Microwave Background Explorer. So this was the first figure that we got, and this basically established the cosmic microwave background, and the scientists who were involved in the project, they also got the Nobel Prize. Then after that, the second picture that you see is something that we got from another such probe, which was named as WMAP. Wilkinson. Now WMAP is also very important for us, mainly because WMAP was the one which also told us about the age of the universe. Age of the universe for the first time is something that was estimated by WMAP to be around 13.8 billion years. 13.8 billion years. So this age that we know today as a fact is something that was established by WMAP. So we get a better, clearer picture of the cosmic microwave background here. And the third image that you see is by another probe named as Planck. So Planck was able to give us even clearer picture of the cosmic microwave background. So cosmic microwave background discovery also established the Big Bang theory further. What next? Big Bang nucleosynthesis. What is the meaning? Very simple. The abundance of hydrogen and helium in the universe. So if you go back to the first picture that we had seen about the composition of the universe, we discussed that you have the rest, you have dark energy, and you have dark matter. In the rest, the 5% that we had, 4% is just freely moving hydrogen and helium, freely existing hydrogen and helium. So freely existing hydrogen and helium in such a big abundance is something which is called as Big Bang nucleosynthesis. So this abundance also has been explained by the Big Bang theory. So this becomes another evidence that basically supports the Big Bang theory. One is Hubble expansion, second is cosmic microwave background, and the third one is Big Bang nucleosynthesis, simply meaning the abundance of hydrogen and helium. So these are the evidences that basically establish the Big Bang theory. Apart from that, there is another one, that the universe must have had a beginning. So that's another evidence that supports the Big Bang theory, so to say. So these things become very, very important whenever you think about the Big Bang theory and why this is the most established, more accepted theory about the formation of the universe. But then we have to understand what are the various phases of the development of the universe. How did we come where we are today? We are saying that it was just a small particle, and today we have a changed world. So how did we arrive at this particular point? And this is where we'll go into little details about what exactly happened while the universe was getting formed. First of all, it started with something which is called as the Planck era. Planck era starts from the Big Bang, you can say 0 seconds, up to 10 to the power of minus 43 seconds. Such a small amount of time. So this is a time when you had this small particle, a particle which was smaller than the size of a proton, a particle that contained everything that you see in the universe today, the particle that contained all the matter, all the energy, the particle that contained all the forces of nature, the particle which contained everything in a soupy kind of a medium. So this was the first step. This was the first stage. And this was the stage which is called as the Planck era, sometimes also referred to as Planck epoch. Then after that, the second step is the grand unification era. So this grand unification era lasted between 10 to the power of minus 43 up to 10 to the power of minus 36 seconds. This is where we say that for the first time we started to see some distinctions between the kinds of forces. So when you talk about the forces, there are four fundamental forces in nature. One, electromagnetic force. Second, gravitational force. Third, strong nuclear force. And fourth, weak nuclear force. Gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. What these are, why these are fundamental, not the subject matter of this chapter. We'll have a discussion on this when we go to particle physics chapter. But for now, just remember this, that there are four fundamental forces: the force of gravitation, the force of electromagnetism, strong nuclear force, and the weak nuclear force. These are the four fundamental forces of nature. So before this, we are saying that all the fundamental forces were one. So after this, we see that the division between these forces start. And then we go to the inflationary era, where what we see is all of a sudden there is an expansion that happens. This is where we see that all of a sudden there is an expansion in the universe, and this small particle now has started to become a big space. This is where all the forces that we have, the forces are separated, matter and energy gets separated, and we start to see the first particles. The first particles will start to come in the reheating phase, starting from 10 to the power of minus 33 seconds up to approximately 10 to the power of minus 10 seconds. What happens in the reheating phase? We start to get some of the subatomic particles like quarks. Apart from quarks, we also have the antiparticle of quarks, which are called as antiquarks. Here, by God's grace, the number of quark particles are much more than the number of antiquark particles. Why? We perhaps don't know. But we just know that number of quark particles were much more than number of antiquark particles. So the quarks and the antiquarks, they start to annihilate. And because they are starting to destroy one another, this is where we see that number of quarks being higher than the number of antiquarks, quarks are left out. All the antiquarks have been annihilated. They have been destroyed. So this is where we enter the particle era. That from the quarks, we see that another kind of particle comes into the picture, which is called as hadrons. Hadrons are formed. And this hadron leads to formation of two of the very important subatomic particles that you know of. One being proton and the other one being neutron. So it leads to the formation of protons and neutrons. So starting from 10 to the power of minus 10 seconds up to the first second, this keeps on happening. So all this that we have discussed, small particle, all the forces, matter, energy, subatomic particles, everything, it all happened just in 1 second. And from the first second, we enter another era where what we see is another subatomic particle comes into the picture, and these are leptons. These are leptons. And there are two very important, and there is one very important kind of lepton which is called as an electron. Just know this for now. No need to go into these details. Just know this happened. So hadrons lead to the formation of protons and neutrons, and leptons in the form of electrons are present here. So because we have protons, electrons and neutrons, this is something that will lead to the formation of the first atom. This will lead to the formation of the very first atom, and this is where you will have hydrogen coming into the picture for the first time. So we enter the next era. The next era is Big Bang nucleosynthesis. Starting from approximately the 10th second and up to the 20th second. What is happening? Formation of hydrogen, formation of helium by the fusion of hydrogen atoms together. So hydrogen formation and helium formation starts to happen in this Big Bang nucleosynthesis. Then after that we enter the photon era, and then this photon era, which starts from the 20th minute and goes on to up to 300 3,80,000 years, that is 3,80,000 years. In this era, we see that the formation of star by the end of it starts to happen. All the hydrogen, all the helium that has been formed, they start to come together. They start to come together and start to form a core. Once they start to come together, once they start to become bigger, they also have the force of gravitation because of their mass. And because of the gravitational force, more and more hydrogen and helium, which are there in the surroundings, in the vicinity, they start to come together. And ultimately, there is a core that has been formed where nuclear fusion reactions are happening. And because of these nuclear fusion reactions, we see that the core of a star is formed. And at the end of 3,80,000 years, we have the first star. This is how the entire sequence of events in the Big Bang Theory happened. And after the first star, you know what happened, led to the formation of many other stars, galaxies were formed, then solar systems were formed, planets were formed. We came into the picture at the end of it. So, this is how the development of the universe might have happened according to the Big Bang Theory. So, just the basics of it, no need to go into the detail of what was happening, how it was happening, what is the meaning of all these different subatomic particles that we are looking at, how the destruction happened, what are quarks, not required here. Just know that this is the sequence of events, how the things happened according to the Big Bang Theory. Now, after the Big Bang Theory, there is one more thing that becomes important here, and that is to understand that there are things that have not been explained by the Big Bang Theory. And there are two very important things that have not been explained. One, what before the Big Bang and what caused the Big Bang is the second. So we are saying that, okay, this particle existed. But what before this particle? How did this particle come into the picture? No explanation. So that's why what before the Big Bang, we don't know. Hasn't been explained by the Big Bang Theory. There are many running experiments, many researches which are happening, but there is nothing concrete to establish as of now. Then after that, what caused the Big Bang? We are saying that yes, Big Bang happened, that this particle all of a sudden had an expansion, but what led to the expansion? What was the trigger for this expansion? We don't know. And again, hasn't been explained by the Big Bang Theory. So there are two important questions that we have that is put forward to the Big Bang Theory, which the Big Bang Theory does not have an answer to. One is what before the Big Bang, and the second is what caused the Big Bang. These are two things that we still don't know. These are two things that have not been explained by the Big Bang Theory. So that's why these two also have to be important from your examination perspective when you are learning about the Big Bang Theory. Now there are other theories as well. For example, we have something called as the steady state theory, which says that there is continuous creation of matter throughout the universe, and this is something which is called as steady state. So expansion is happening, but what we know is that it's not a uniform expansion. It's an accelerated expansion, and this is something which is not explained by the steady state theory. So that's why this is one theory that has been discarded. Then after that, we also have something which is called as an eternal inflation theory. When we talk about the eternal inflation theory, this is a theory which says that, okay, Big Bang happened, formation of universe happened, but it's not one universe that was formed. There were many universes that were formed together, and even today there are new universes that keep on forming all the time. So that's why it gives us a concept of multiverse, which again theoretically looks fine, more as science fiction rather than as a theory. So there are not many believers of this theory. Then after that, we have the oscillating universe theory. What the oscillating universe theory says is that the universe will keep on expanding and contracting all the time. So now we know that, okay, there is an expansion that is happening, but ultimately there will be a contraction which will happen, and then again another expansion will happen, and this is something that will keep on happening. So according to the oscillation theory, it is Big Bang and Big Crunch. So Big Bangs will be followed by big crunches, and this is something that will keep on happening. Again, this is one theory that has not been explained much. There are not many believers of this theory as well. The next theory that we have is the Big Bounce theory. Now when it comes to the Big Bounce theory, this is a theory which is also very similar to how oscillating universe theory talks about the universe, but at the same time you have to understand that Big Bounce theory does not talk about singularity, but it talks about a state of universe where the universe will keep on contracting and expanding, but it will work on different principles. And the principle that it will work on is quantum loop gravity. Now, we don't need to go into the details of what's the meaning of quantum loop gravity, but just understand this, that generally when we are talking about gravitation, the force of gravitation does not work at a very small scale. That, for example, you talk about gravitation between the earth and the moon, or between you and the earth, correct? But we don't talk about the gravitational force between two atoms or two molecules. But the quantum loop gravity theory, if it works, if it is proven to be right, then in that case gravitation could work at that level as well. So that's a completely different story, and we don't need to go into the details. Just remember that this is a model that also works in a manner which says that the universe will keep on expanding and contracting from time to time. All right. So if you look at this particular picture, this is what the theory says, that the universe will first be an expanded universe, then it will keep on contracting, and then after that it will again expand, and then it will again contract, and this is what will keep on happening. All right. So this is what the Big Bounce theory says. Now, the next theory that we have is the string theory. Now, string theory basically says that the entire universe, everything that you see, is basically made of small, tiny strings. And the vibrations in these strings will produce basically what we see as the universe. So, it's not mainly about the formation of the universe as such, but rather it is about the structure of the universe and how the universe can be perceived. So, it says that the entire universe, everything that we see, is basically made of strings. The vibrations in these strings will produce the different kinds of substances and everything that we see. So you can just imagine a guitar, just like a guitar, how the vibrations in the strings of a guitar will produce different kinds of music, different kinds of notes. Similarly, all the matter that we see can be produced from these vibrations that will happen in these strings. So this is what basically the string theory says, describes the fundamental level of the universe in terms of vibrating strings rather than particles. It is considered as candidate for theory of everything as it tries to explain the four fundamental forces. And this is very, very important, because when we talk about string theory, what happens with string theory, physicists who believe in string theory, who have been working with string theory, they say that if string theory is proven to be right, then in that case it will lead us to theory of everything. What's the meaning of theory of everything? If you remember, we talked about the formation of the universe, and the formation of the universe, the first stage, we said that before how we see the universe today was perceived, we know that everything, all the matter in the universe, all the forces of the universe were one. Correct? They were one single particle, a single particle which was even smaller than the size of a proton. If you remember, we discussed this. Correct? So, if string theory is proven to be right, then it will help us in understanding how the unification of forces would work. How all these forces that we see as four different fundamental forces, that is, the force of gravitation, the force of electromagnetism, strong nuclear force, and weak nuclear force, all these forces could be unified. Currently, as you all know, that all these forces have not been unified in a single equation, in a single mathematical equation. You have a different formula for gravitation, you have a different formula for the force of electromagnetism, and so on. Correct? So this is what the scientists believe. Then after that, there is also the simulation theory, not a part of your syllabus in any way, just that it says that everything is a part of a big simulation and somebody is running the whole simulation. So you are more like a video game in this simulation. Let's look at this one question that had come in the 2017 paper in the prelims examination. The term event horizon, singularity, string theory, standard model are sometimes seen in the news in the context of singularity, string theory, event horizon, standard model. Now, let me go back to the string theory here. In string theory, we are talking about the four fundamental forces. Out of these four fundamental forces, which are the force of gravitation, the force of electromagnetism, strong nuclear force, and weak nuclear force. All right. So out of these, gravitation, as we just discussed, that gravitation works only at macro level. It does not work at very small levels. And it is actually the weakest of all the forces. Of all these four forces that we have, gravitation is the weakest force. So that's why what happens is, when we take standard model, or when we do the study of the universe as such, we do not actually do the study with the help of gravitation, because it's a very small force. So that's why we don't really get a lot of findings. A lot of studies cannot happen with the help of gravitation. So the standard model, as something that we call as the standard model of physics, the standard model basically takes only these three forces into account. So let's come back to the question. You have four options: observation and understanding of the universe, study of the solar and the lunar eclipses, placing satellites in the orbit of the earth, origin and evolution of living organisms on the earth. I'm very sure that all of you know what the answer would be. Answer could be A, observation and understanding of the universe. Study of solar and the lunar eclipses. We have not talked about any of the eclipses, right? So this cannot be the answer. Placing satellites in the orbit of the earth. Not necessarily. Origin and evolution of living organisms on the earth. Even this cannot be correct. So the correct option will be observation and understanding of the universe, because we just discussed about string theory, correct? We just discussed about string theory, and string theory basically talks about observation and understanding of the universe.